Hey, so welcome back, and this is another daily Leetcode problem. So today it's called check if there is a valid partition for the array. And so essentially what you're given here is just an array called nums. We want to be able to partition it such that we can return valid subarrays. And so what that really means is we can basically split this array multiple times. We can split into one or more different subarrays here. And the only catch here is that it has to be kind of contiguous, which just means that basically when you make these splits, you can't kind of alter their positioning. So you couldn't put 4 over here or something, or 6 into this subarray. So they have to be kind of statically split. And now the constraints for this is we want to return true or false if we're able to partition or split this array into valid subarrays. And basically what makes them valid is these 3 conditions here. It's really wordy, but it's super simple. A subarray is valid if one possible path is that there's only 2 numbers in the subarray and they're equal. So that would be like 2, 2, or say 4, 4 in that case. Or another possible path is that, okay, the subarray is valid if it has a length of 3 and they're all equal. So that would be like 4, 4, 4 in this case. And they use 4, 4, 4 in this example as well. Or the third possible thing that makes it valid is that if the length is 3 and the subarray has like increasing elements, so 4, 5, 6, or 3, 4, 5. Now the catch here is that 1, 3, 5 does not work, and that's because it has to be increasing by basically 1 with each element. So it has to do like 1, 2, then 3, or 2, 3, 4. You can't kind of do like 1, 3, 5. All right, and so if this, for this example, the only possible path would be by splitting it here, or sorry, not there, by splitting it here. You can see this is valid because it meets the first condition, and then this second subarray is valid because it meets this third condition of increasing elements. All right, and so this one's not valid because there's no way you can kind of partition it so that all these subarrays meet these 3 different conditions. Okay, and so when I thought about this problem, the first thing that I thought of was to do like a recursive solution. I thought about backtracking, but really I ended up coding like a dynamic programming solution. And so what you can kind of think of is, say if we start at index 0, we want to see if we can go down any of these 3 different paths from this first index. And what you can see is, okay, we could either say 4, 4, or we could do 4, 4, 4. So basically the first and second conditions are 2 valid paths. And so say if we decide to take a subarray here and partition it here, then we could basically hop over to index 2 in this case and kind of move on from there. So one possible path is to jump to index 2 by using this first condition, so kind of condition number 1. All right, or we could use condition number 2, which is this one where you're using exactly 3 equal elements. And so what that looks like is basically we are saying, okay, let's split it here and then basically hop to this third index at 5. And so we can basically hop to 3. If we expanded it from there, we could use basically the number 3 condition here by saying, okay, say if we're at index 2, which is this one here, we can look at, okay, this is 4, 5, 6, so those are increasing elements, so that satisfies this half of the subarray as true as well. And so we can basically return true in this case because, well, we kind of reached the end of the subarray and we got our result. Okay, if that doesn't make much sense, I think me coding it up will really help with this. So essentially, typically what you do for these top-down memoization approaches is that you say, okay, let's write a recursive function that will return our result. And so you can just define that up here. And so we're going to pass in just one parameter I, and that just kind of represents the index that we're currently at. So I kind of showed you that you start at index 0 and you kind of hop to index 2 or index 3. And so that's what you're keeping track of, is the index that you're kind of pointing to in the subarray as you move along. And so we want to define our base case. And what that was is, okay, once our index hits the end of the array, just kind of what we did, once we got to the 5th index here and kind of satisfied this using number 3 here, and we kind of hopped to index 5, which is out of the array, we could return true because we reached the end of the array. And so basically, okay, if I is basically equal to the length of the array, then let's just go ahead and return true, as that's a valid path or partitioning. And so with this, what we want to do is kind of look at all these 3 different possible options and see if any of them return true. And so in order to do that, what I quickly thought of is you definitely want to keep track of like how many elements are in front of you. So you kind of want to know, say if you're at index 6 or 4 here, you know that if you're at this position, there's no way you can satisfy any of the 3 conditions because you need at least 1 or 2 elements in front of it. And so to keep track of that, let's just say how many elements are in front of me. We'll just define that as like the distance. And so all that is basically the length of the numbers subtracted by your current position in the array. And so this allows us to know, okay, is there at least 2 or 3 numbers in front of us? Otherwise, let's just return false. So if the distance is greater than or equal to 2, we can look at, see that, okay, maybe it can satisfy this first condition. Otherwise, if it's greater than or equal to 3, we can look at to see if it satisfies either of these 2 conditions here. Otherwise, we can just go ahead and return false because we need at least a distance of 3 or 2 in front of us to meet these possible conditions. And so from here, let's just say that, okay, if the distance is greater than or equal to 2, then what that means is that, okay, maybe we can satisfy this first condition. And so that would be if the current number at I is equal to the number ahead of it. And so as long as we kind of move forward from there and we find possible partitions that work there and those return true, then we can just propagate true up the chain. And so basically we would want to recurse here at I plus 2. And that just means that, okay, say if we're at index 0 here, and we see that, okay, 4, 4 works, let's just hop ahead to I plus 2, which is index 2 here, and carry forward from there. And if that returns true, then let's just return true entirely. We can do something similar here, which is basically if nums at I equals nums at I plus 1, which equals nums at I plus 2. But just because that's really wordy, we can just kind of put these into variables here. So current next and basically next, which is nums at I, nums at I plus 1, and then I plus 2. And so as long as, and I'll just write this out here, if the current is equal to the next number, which equals to the next number, and I plus 3 returns true, then that satisfies that second condition here of 3 consecutive equal numbers. And then finally, we just want to consider this third possible path here, which looks like so. So basically, if the current number is equal to the next number minus 1, which equals the next number minus 2, if we kind of hop ahead and that returns true as well, then we just return that result up the chain. The reason why we do minus 1 and minus 2 here is, once again, these are increasing numbers by at most 1 step. All right, so if none of these paths end up returning true here, so the third condition, the second condition, or the first condition, if none of them end up returning true, then we just want to return false in that case. The only other thing that we have to do here is just to cache this, because if you don't, if you look at my submissions, I forgot to actually, and you get a time limit exceeded on some really big inputs. So We just got to make sure that we cache the answer, and let's go ahead and try submitting it. And success. So that's today's daily Leetcode problem. So I hope that helped a little bit, and thanks for watching. Good luck with the rest of your algorithms.